Okay, class. So last time at the end of class, we were doing the fiber optic problem. And what we had done is we had figured out what the cost would be to lay the cable in a kind of a variable sort of manner where we would go a certain distance here, X, and then go across that distance we called Y. And then we manipulated everything and we were able to get a cost function that was a function of a single variable X, which was this. We also said that X must be between 0 and 2000. And then we were using the method of 4.1 that we were going to try and find the absolute minimum value of this cost function on this closed interval. So we had to take the derivative, which we did in class. And now we're going to find the critical number. So we're going to set it equal to 0. So that I did not do. I'm going to go ahead and do that for you. This is the derivative of the cost function being set equal to 0. I'm going to try and solve this algebraically. So first thing I'm going to do is I'm going to move everything here that's negative, all of this. I'm going to move it to the other side of the equation, and that'll make it positive. So I think I'll cheat to do this. Just going to copy this, paste it. There's good. And then let's make this an equals. So that's what would happen if we move that to the other side. Then what I'm going to do is I'm going to not cross multiply, but I'm going to multiply both sides of the equation by this square root thing. And what that's going to do is clear the fractions. So I multiply by this square root on this side, and then I do the same thing on this side. All right, it goes way over here. And then I have 470 times that square root thing equals the numerator. I'm getting my calculator out here because I'm going to need it. So I have 470 times the square root of this thing. Okay, equals the right-hand side, which is just 710, and then times 2000 minus X. Okay, so this is now a radical equation. So I need to get rid of that radical. So I'm going to square both sides of the equation. What I think I'll do first is I'll divide both sides by 470. Doing this on my calculator. So if I divide both sides by 470, we'll go away here. I'll have the square root of this stuff here. Equals, let's see, this is about 1.511. I rounded 3 decimal places, and then times 2000 minus X. Okay, now let's square both sides. So if I square the left side, the square root's going to go away. And when I square the right side, I got to be real careful. So the left side now becomes this. Okay, and the right side, now what I'm going to do, because there's multiplication here, I'm going to square the 1.511, and then I'm going to square this thing. So I'm going to take the 1.511 and square it on my calculator. I get 2.283. And then I'm going to have the 2000 minus X. That thing's got to be squared as well. Okay. What can I do next? There's a lot of things algebraically I can do. Let me go ahead and square. I'm going to square this, and I'm going to square this. So that means I'm going to take 2000 minus X and multiply it by 2000 minus X. So when I do that, again, you may need your calculator here. 1, 2, 3, 4, 5, 6. And then, so that's this times this. And then here to here, that's going to be minus 2000x, then another minus 2000x, so minus 4000x. And then the last one will be plus x squared. So that's what I'm going to get. So I have 150,000. Okay. And then I have plus what we just got when we squared that. and then equals, and then I'm going to get this right here, but it's got a 2.283 in front of it. So I'm going to distribute that through. It's got to distribute to each of these terms. So I take my 2.283, multiply it by that, what, 4 million, and I get 9 million. Hold on. Okay, so I get 9,000,132,000, and then I do the 2.283 times 4,000. So I get negative 9,140x. Let me just double check that 4 million again. Wasn't sure if I typed, yeah, I did type that in right. And I have to distribute it to the x squared. So I'm just going to get plus 2.283x squared. Okay. So hopefully you understand. I took this 2.283 and I distributed it through to this because that's what this thing is. Now this is a quadratic equation. So I'm going to move everything to one side. So I'm going to move everything to the right and subtract x squared. I'm going to add 4,000x, and I'm going to subtract 250,000. Okay, so on the left, oh, I forgot I got to subtract 4 million. Okay, so subtract 4 million. Okay, that'll make this side 0. And this side over here, let me just get on my calculator and do this. So I'm going to do this one first. That minus the 250,000 minus the 4 million. So I get 4882000. So 4,882,000, something like that. And then what's that? Minus 5140x, and then plus 1.283x squared. All right, there we go. We've got a quadratic equation. Now I'm going to use a quadratic formula. So this is my A, this is my B, negative 5140, and this is my C. So I'm going to use quadratic formula. Negative B, which would be the opposite of negative 5140, which would be positive 5140, plus or minus the square root of. Now I've got to square this number. Be huge. 26419,600 minus 4 times A. A was 1.283 times C, which is 4882000. Then all of that divided by 2 times A, which is 1.283. Okay, fun stuff. 5140 plus or minus the square root. Okay, let me try and, I'm going to do all this on my calculator. 26419,600 minus 4 times 1.283 times 4882000. So underneath the root, I get 1365176 all over. Let's see, 2 times 1.283 is 2.566. Okay, let me take the square root of that number. 1365176 square root. So here's what I've got: 5140 plus or minus 1168.41 all over 2.566. This gives me 2 different answers. Okay, one answer is when I do the plus, the other one's when I do the minus. So let me do the plus one first. 5140 plus 1168.41, and then I divide that by 2.566, and I get 2458.46. And if I do the other one, 5140 minus 1168.41, and then divide that by 2.566, I get 1547.77. Okay. Woo. Okay, so I have two critical numbers. Here they are. But remember that we were on the interval between 0 and 2000. And so this one is outside of that interval, so I'm not going to look at that. So what I need to do now is I need to take my cost function and I need to plug in the two endpoints and the critical number and see which one gives me the smallest answer. Because remember, I'm trying to get the minimum cost. So I've got to go back to my cost function, which was back in my notes. Oh, wait, hold on. The end of class. Here's the cost function right here. Let me copy this. So I need to take those answers and plug them into this. Okay. Try and get rid of that. There we go. Oops. I'll just leave the square root there. Okay, so let's first try and do the cost at 0. Let's plug in 0 for all the x's. We're gonna get 0 here plus 710 square root of 250000 plus, if I plug in 0 for x, I get just 2000 squared. Okay, I'm gonna do that on my calculator. 250000 plus 2000 squared. Okay, so this is 710 times the square root of 4250000. Okay, let me just do that on my calculator and tell you the answer. I get an answer here of 1463702.49, or close to that. That's how much money it would cost to do x being, if we let x be 0. Okay, so I don't know if that's the smallest value yet. I now need to plug in 2000 into this. Okay, so let me do this on the next page. Okay, so now what's the cost at 2000? We know the cost at 0 we just got was $1,463,702.49, something like that. Now the cost at 2000, if we let x be 2000, would be 470 times 2000 plus 710 times the square root of 250,000. And then notice when we plug 2000 in right there, it kills that off. We just get 0 squared, which is 0. So that's it right there. I'm gonna do all that on my calculator now. Okay, I did all that on my calculator. I got 1,295,000 even. That's how much it would be. Okay, and then I have to do my critical number, 1547.77. 1547.77 getting plugged in here would be 470 times 1547.77 plus 710 times the square root of 250000 plus 2000 minus 1547.77, but then that's squared. Okay, 470 times 1547.77. This gives me 727,451.9 plus, oh man, this thing is a pain, plus 710 times the square root of, okay, let me do all this. I'll do this all on my calculator. So I'm doing 2000 I'm taking away the 1547.77. So I did what's in here first on my calculator. Now I'm going to square that answer. And then I'm going to add the 250000. So underneath here, I get square root of 454511.97. Take the square root of that. I get 710. 710 times 674.17. And in front of that, I had 72745.1.9. So I'll put that all together. That number, 674.17 times 710 plus 72745.1.9. Final answer here, 1206112.60. So 1,206,000. So let's compare these. We have 1,463,000 if we do it that way, 1,295,000 if we do it that way, and 1,206,000 if we do it that way. This is definitely the way to go, right? It's going to save us a significant amount of money compared to these two. In fact, compared to this one, it's like 90,000, roughly $90,000 cheaper. So, all right, that's it. I just wanted to show you, really what I wanted to show you is how you solve this algebraically, because it looks terrible, but it's just algebra. And then just plugging in the numbers. So that's pretty much it. Just wanted to share that with you because I won't have time in class for that. So there it is. Hope it makes sense. We have found that the best way to do this, let me just kind of summarize here. The best way to do this is to actually start here at A, go down here, that distance, you want that distance to be 1547.77 feet. Okay, and then what you'll do is you'll go straight across the river from there to there. That'll go underwater. And if you do that, that will be the cheapest way to do it. And it will cost you $1,206,112.60. Oops. And 60 cents. And there's no better way to do it. That's the cheapest way to do it. All right.